hydrogen reacts with oxygen to form water. And we saw the reason why this chemical equation is unbalanced. The number of oxygen atoms on the left is not equal to the number of oxygen atoms on the right. The important question is, can we balance this equation? The answer is yes. Let's go step by step and see how we can balance it. As the first step, it's always a good idea to draw boxes around each element or compound, like this. Why did we draw these boxes? It's because nothing inside the boxes can be changed or altered when we are balancing the equation. You'll understand better soon. Next, we form a table like we've already drawn here. This row in the table tells us that the number of atoms of oxygen on the reactant side is not equal to that on the product side. It's 2 on the left and 1 on the right. So let's try balancing the oxygen atoms first. As there's 1 oxygen atom on the right and 2 on the left, we multiply H2O with 2. What we have here is a partially balanced equation. The number of oxygen atoms on the right is 2 and that on the left is also 2. Also remember that you cannot alter the formulae of compounds or elements involved in the reaction, which means that to balance the oxygen atoms, we cannot change H2O and write it as H2O2. This would be incorrect. Let's go back to the partially balanced equation. The number of oxygen atoms on each side is balanced now. But what about hydrogen? When we multiplied this compound with 2, what happened? The number of oxygen atoms were equal on each side, but what about hydrogen atoms? The number of hydrogen atoms on the right became 4. And what's the number of hydrogen atoms on the left? It's 2. So how do you think we can balance the hydrogen atoms now? We can multiply the hydrogen on the left-hand side with 2 to get this. Is the equation balanced now? Absolutely. We can form the table and verify it. This is what you'll get. So we simply multiply the appropriate elements or compounds as necessary to balance each and every element. When all elements are balanced, we say that the chemical equation is balanced. Easy, wasn't it? Why don't you try balancing this chemical equation? You'll see the solution in the next part of the lesson. This was the equation I had asked you to balance. What's the first step we can do? We draw boxes around each element or compound. The purpose of these boxes is to make sure that you don't change anything inside the boxes. Whatever you want to multiply, you do it to the entire box and not just one particular element. Next, we populate this table. In the first column, we write down the different elements involved in the reaction. And then in these two columns, we write the number of atoms each element has on each side of the equation. Why don't you try filling up this table? Which are the elements or atoms present in the equation? Iron, hydrogen, and oxygen, that's right. If you've not tried it yet, try filling up these two cells for each element. This is how the table would look. You see that iron and oxygen are not balanced in this equation. So the important question is, which atom should we start balancing first? Should it be iron or should it be oxygen? That's where the third step comes in. Look for the atom which is maximum in number on any side. If we look at this table, the maximum number is 4 and it's on the right. Oxygen in this compound has 4 atoms. So our first aim will be to balance the oxygen atoms. On the right, it's 4 and on the left, it's 1. So to balance the number of oxygen atoms, we multiply this compound with 4. So the number of oxygen atoms on each side is 4 now. This is a partly balanced chemical equation. But the iron and hydrogen atoms are not balanced now. When we multiplied this compound with 4, the number of hydrogen atoms on the left became 8 and that on the right is still 2. As the number of hydrogen atoms is 8, Let's proceed with balancing the hydrogen atoms next. As it's 8 on the left and 2 on the right, we multiply the hydrogen on the right with 4. Is the equation balanced now? The number of oxygen atoms on each side is 4 and the number of hydrogen atoms on each side is 8. And what about iron atoms? It's 1 on the left and 3 on the right. So the equation is just partly balanced. So to equalize the Fe atoms, we multiply Fe on the left with 3. Is the equation balanced now? Yes, it is. The number of atoms of each element is equal on both sides of the equation. 3 of iron on each side, 8 of hydrogen on each side, and 4 of oxygen on each side. You'd have noticed that there are no fixed steps to balance a chemical equation. We just try balancing each atom at a time, which is why it's called a hit and trial method. We make trials to balance the equation. Though we've balanced the chemical equation, there's one additional thing we can do. We can write symbols of the physical states of each reactant and product. What do I mean by this? There are 4 main states of the reactants and products: gaseous, liquid, aqueous, and solid. We know these 3, but what's aqueous? The word aqueous is written if the reactant or product is present as a solution in water. So the balanced equation we got can be written like this. This clearly gives us more information about the equation or reaction. These 2 compounds are in solid state, and notice that G is written next to water. It means that water was used in the form of steam in this reaction. And sometimes there are conditions under which the reaction occurs. Conditions like temperature and pressure are written above or below the arrow. So if 2 reactants A and B react at 100 degrees Celsius to give C and D, it is written like this. If the reaction requires sunlight, it can be written like this. Would you like to balance a couple of chemical equations by yourself? Here you go. Tell us your answers in the comment section below. Before we move on to types of chemical reactions, let me ask you a simple question. Look at this reaction. A plus B gives us AB. What happened here? If you were expected to use layman language to explain this, how would you say it? You'd probably say that A and B combined to give us AB. And there it is. You just said it. Such reactions are called combination reactions. The best example of a combination reaction is formation of water from hydrogen and oxygen. Even burning of coal is an example of a combination reaction. Coal uses up oxygen in the air to give out carbon dioxide. In both cases, the reactants combined to form one product. So how can we understand combination reactions in simple words? It's easy. In a combination reaction, 2 or more reactants form a single product. Note the words 2 or more. So even a reaction like A plus B plus C forming ABC is a combination reaction. Now let me give you another example. How would you describe this equation? Here you'd probably say something like AB is broken down into A and B. A more sophisticated word would be decomposed. Decomposition generally means breaking down into simpler components. Such reactions in which a single compound breaks down into simpler substances are called decomposition reactions. Another simple way to understand it is by knowing that they are the opposite of combination reactions. The electrolysis of water into oxygen and hydrogen gas is an example of a decomposition reaction. Decomposition of calcium carbonate to calcium oxide and carbon dioxide on heating is another example. Let's quickly review what we learned. A combination reaction is a reaction in which 2 or more reactants react to form a single product. And a decomposition reaction is a reaction in which a single compound breaks down into simpler substances. Are these two the only types of reactions? Watch the next video to know more.